Hello. Hello, Rahim.
Hello, hello.
Yeah, I'm here to accompany you in the Zoom since Rich is outside.
Gotcha.
Okay.
Hello?
Hello, hello.
Hey, oh. Ryan, is this thing, do you have host control? Is this thing currently recording?
Yes.
Okay, fantastic. You have it. I gotta actually run into the office for the in-person, but before we basically get started here, Luke is here. Okay. Estevez, can you do me a gigantic favor? Can you go ahead and accept James's LinkedIn invite? Estevez? We can't submit you until you accept James' LinkedIn invite. Anyways, Raheem's got a fantastic session for y'all. Again, this is week two, session one, and the marketing engineering cohort is set to start on September 7th. If you guys have been procrastinating a little bit on your Cloud Certified Architect Foundations, I can assure you that is no longer a luxury for you anymore. Please step on it. Raheem, I'm going to go ahead and actually let you take over, and then let's go ahead and catch up later tonight.
Great. That sounds good, Rich.
Okay, thank you. Great session, everybody.
Okay, let's get started. There we go. We do a slideshow. Oop, let's start session. All right. Thanks for everyone for coming. Please log into these polls because we'll be doing some live polls throughout the session today. Today's main focus is prompt engineering, and then we'll cover structure outputs next session. Specifically, we're doing the subdomains of explicit criteria and few-shot prompting. And just to get started, just to get a feel for everyone where they're at, I know I asked this last week as well. How many of you guys have finished the skill jar courses? That's like the baseline for being able to even understand some of these domains. Oh, you might not be able to do it here. Sorry. And let me know. We'll give people a minute to log in. The QR code should work. Yeah, we start with domain 4 because I think most people have interact Claude. You primarily interact with it, only really interact with it with prompting, basically, right? You're having a chat with it. So this is a good place to start. Oh, there we go. We got one. Let's give it another couple seconds, see if anyone else joins on. I see there's about 4 of you. Once again, this is the login information. If it's only one, we can skip the polls, and then I can try giving you guys some chat, and we can just do some direct teaching. Okay, 2. Here. So we got what? So 5 people. I know it's an easy question, but making a little interactive helps, and then I can figure out where people are at. But that's 2 minutes. So yeah, let's just go through it then. Yep, for today's agenda, we're gonna first cover sort of a high-level mental model of actually working with LLMs, which is what Claude and Codex are. Then we'll go through the first subdomain, which is explicit criteria, which is really based on like the difference between categorical and semantic. Then we'll do few-shot prompting, which is more for judgment and sort of tasks that are hard to decompose into words. Then I will give an example of sort of explicit criteria is mainly used for, or like primarily used for CI/CD pipelines, and then few-shot prompting is pretty heavily used in data extractions, and we'll get to that. All right. So yeah, end of the session. I want you guys to be able to tell the difference between when to do explicit criteria and when to do few-shot examples, and then sort of you can make the right intervention. The big difference between the two, like I said before, is explicit criteria is sort of trying to find decision boundaries. We'll give you more examples as we go through. And then few-shot examples are mainly for inconsistent judgment and formatting. Let's keep going. So yeah, this is sort of like the high level of Claude or LLMs. They're stateless. They don't like what they're really doing is they're predicting the next token. A token is just like a unit. It's not necessarily a full word. If I remember correctly, it's about like if you give a text, about 0.75 of a word is one token. To give an example of why like tokens aren't entirely words, one example is like contractions, right? Like doesn't or yeah, doesn't, because like it's do and then not do, right? So like there's information in that negation. And so that's an example of sort of splitting a smaller word into, or one word into smaller words with meaning. There's also no like, there's no database when you're talking to Claude, right? If and when you do the Claude certified API course, you'll know that like when you send a prompt or any kind of stuff to Claude, it comes back and it responds, but it doesn't carry state of what questions and what you've done with it before, unless it has like it's in its context. Um, so it's sort of like, yeah, if you don't paste the entire history of the conversation, it won't know how to respond next. And that's an important notion because if you realize as we talk to Claude more and more, right, more and more the conversation grows. Every time we send a message, that entire chat history is passed along with it, right? If you don't put the history on it, it's like it never happened. Also, one of the big things for LLMs, they are stochastic, which is similar to the word probabilistic. There's a little difference, but you can think of it sort of, there's a probability distribution of what the response can be, and it'll pick, probabilistically. It's not necessarily like if you enter the same prompt every time, it's not guaranteed to give you the same output. And then for that, there's a lot of like, if you want to ask questions later, it's not really good being covered in the exam. But like when you're doing actual like AI stuff, you're going to want to test your prompts by like, seeing how sensitive it is to changing of words or specific things in your prompt. And that's sort of like a really good skill set to build, though that part isn't covered in the exam. Yeah, let's go next. So yeah, here's something before. Context window is everything. You send the entire history every time you talk to Claude. That thing grows. Context window is pretty big now. I think it's like 500K, which is like a small medium sized book. So there's a lot of context. And then yeah, message APIs, they're all stateless. There's no history. Claude doesn't keep a history. Therefore, yeah, you have to send it every time. So yeah, explicit criteria. This is sort of really big in the domain of CI/CD. You want to create prompts that really improve precision and reduce false positives. To go back on that, the good example of precision and recall and then sort of false positives is the colloquial what's it called, fire alarm, right? If your fire alarm, right, it has high recall but low precision, that means that you're cooking and your fire alarm is going off, right? And as you do anything else, like it picks up from your cooking, but like it's not really a fire, right? But its recall is high, right? It's warning you, but its precision is low, right? Because it's not sensitive, right? On the flip side, you could have a fire alarm that doesn't go off when you're cooking, right? But like maybe if there was a small fire, it wouldn't register. It'd have to wait till it gets to a certain level. So high precision, but low recall, right? Because it's not gonna go off for any little thing. And the main takeaway from that here is sort of you want to reduce false positives, right? False positives being like this was an issue, but it wasn't an issue. And this is heavily used sort of in CI/CD because the pipeline, it wants to look for like bugs or any kind of issues that should be caught before, entering the code base. So you want to reduce the false positives because this is a common theme. If you have a bunch of false positives, the teams that you interact with are gonna lose not respect, but they're just gonna ignore the outputs, right? So like if you keep getting small, like again, oh, this is an issue, and it's like a small thing that doesn't really affect anything, you're gonna learn to ignore those issues that are raised. So yeah, the biggest one is sort of like, so this is the semantic versus categorical. So let's do semantic first. Semantic is like, okay, we have two bouncers. We're at the club. bouncer one gets the instruction like, don't let anyone shady in, don't let anyone who looks suspicious, right? It's semantic in the sense that it's subjective to that person, right? And then on the flip side, if it's categorical, this is your traditional like no shirt, no shoes, no service, right? It's a like a checklist of sort of like clear, defined things that if you were to follow it, right, like it's more clear, right? Like if you give the semantic bouncer instructions to another person, there's a good chance, no, it's almost 100% chance that that person's interpretation of that instruction is different, right, based on their own individual biases. So this is why you notice this. A lot of people do this in the prompts. People are like, be conservative, don't make mistakes. Give me the high confidence. These are all semantic instructions. So they're biased, right? And then not biased, but like they're influence of bias of the current model and its context. So yeah, you don't want to, you want to switch to something more categorical. So my analogy is here, like I said before, the smoke detector, you just started ignoring it. I come from a data engineering background, right? Or if you ever use SQL, the where clause, like it's like giving a where clause to a query, but not defining this explicit instruction for that where clause. Talking fast. Yeah. So here, so the main thing with explicit criteria is you're trying to figure out the decision boundary, right, between things. So let's look at this one. So before we can say check the comments are accurate, right? It's very vague, left to interpretation. It's not, explicit, right? And after you would want to adjust the prompt. I'm talking really fast. Adjust the prompt to like, so you want to report, give it like instructions of when to report it. And say, you also want to give, in addition to that criteria, you want to give the reasoning behind it as well, right? So this one's like, comments claim specific behavior that contradict the code, right? This is like saying like, give me a user ID, and then it returns null as a possibility, right? That's a big bug, so you want to report it. Skip when, right? Outdated parameter name, so something that's like smaller. I'll show you a checklist later. And then severity is sort of, critical, any kind of high, really, really big issues that are material in terms of its damage. But yeah, so like you can see when you put the report, the skip, the severity, and the reasoning of why you pick those things, you'll get a much better response that is more structured and sort of, it knows the boundary between two things. Okay, yeah, explicit criteria, what to remember. Yeah, so you're trying to figure out the boundary between two things. District boundary. Yeah, picking between whether report it to skip it. Once again, most of these examples are in the context of CI/CD. I guess I should explain, because I'm not sure all of you know what CI/CD is. You can think of it as like, we're in a commercial kitchen, all the software engineers are like cooks, right? They're cooking the stuff. And then they put it out for plating. And sort of there's like the master chef, right? Who checks and looks at the dish before it goes out to the customer. You can think of it like that, right? Where he's going to check to make sure that there's no major issues, or like the dish isn't prepared the way it's supposed to. That's like a kind of, it's not completely one-on-one accurate, but I think it helps to have a little bit of understanding of like what we're trying to do with the CI/CD to get value. Right. So then other patterns, remember, like I said before, the subjective threshold. You don't want to be vague or have, instructions that won't necessarily return the same thing every time. You can try this too, right? You can like, talk to your LLM, give it a prompt, and then, give it another prompt on a different instance of the same, another chat in Claude, and you'll see that it'll give you different answers. Severity rubric, that's sort of just a coding standard of like, critical, important, medium, and then like low being like stylistic thing that a linter would catch. Categorical criteria, like I said before, is sort of, a very specific condition that's easy to verify. And then precision versus recall is the difference between the fire alarm that goes off every time it gets even a little bit of smoke, versus the fire alarm that doesn't go off all the time, but may not warn you to the fire as early as the other fire alarm would do. All right, so let's go common failure modes, right? These are going to be sort of the questions you're going to get. We're going to go through each line right now, pretty slow. Right, so be conservative, make no mistakes, stuff like that. There's no boundary, so every time it runs, it's going to be something different. The best way I can describe this to help you as well is, I don't have my pen. When you're looking at so LLM, right, predicting next token, right? So it's literally like, if you notice when you talk to ChatGPT or Claude, it's you hit enter, right? It thinks for a little bit, and then the tokens start to flood in, right? So it's, what was I going to say? It's probabilistically thinking of at each individual predicting of next token, there's going to be a distribution of words, right? And it's going to pick not randomly, but each words has its own probabilistic weight, and it's going to pick that next token based on that probability, right? And a good way to think of this would be the big red blank, right? So I have the big red, right, to the LMM, and it's trying to predict the next word, right? So one of the words could be balloon, the big red balloon, or it could be the big red car or the big red truck, right? So from that context from before, all the previous tokens, and then that last token, it's going to have a distribution of different kinds of words that could be next, and it's going to pick it not randomly, right? But it's based on the probability of what it should be, what the next token should be. So yeah, there's no boundary. So be conservative. You want to replace with a name and a checkable condition. Next one would be only report high confidence findings. Confidence is undefined. Another issue too, not necessarily in this subdomain, but for the exam, is when you say report high confidence to yourself, it may also have a bias on what it thinks is high confidence. So you may want to give that downstream to a different model. And then the fix here, yeah, is still categorical criteria, and not a threshold word, because once again, this is all semantic versus categorical framing. Everything possibly wrong, right? So this is more about getting flooded with responses, right? If I don't know if you guys ever been on call before, but one time I joined a company, and I was a data engineer at the time, and so we had a bunch of pipelines, right? Thousands of pipelines. But for some reason, architecturally, somebody decided that every single success and failure was routed somewhere, but the successes were routed to my email. And when it was going to my email, you get 100, 150 emails a day. And at that point, when you're flooded with so much of something, you start to ignore it, right? It's not useful, right? There's no way you can put enough time in to do it. So this is why you want to have when you're doing any kind of LLM on terms of reporting things that are issues, if your criteria is too lax, it's going to flood, and everyone's going to lose interest. This will come up in the exam too. This is one of the most common framing, right? Whereas you're in charge of reporting issues with code being pushed, which is the CI/CD scenario, and it wants you to say what should you do with your various pipelines, right? So your various pipelines is the right word. Let's say, so flooding, they want to do CI/CD. The big one, yeah. So you may have a couple different pipelines in terms of the CI/CD in correcting it. Question that's asked a lot is what if you're getting lots of false positives, right? This is one of the big one for this section too, is false positives. Because it deteriorates, like I said before, the trust in the system. So the most common, fix for it is to actually take down the pipeline so that those high flood false positive flagging goes away, and then you're going to want to iterate through it, to increase it, to reduce its false positive rate, and then reintroduce it. But yeah, so that's going to be one of the most, you probably see at least 2-3 questions of that in the exam. All right, so like next, let's look at the noisy category. Yeah, so here I was talking about. So yeah, you disable it, you fix the criteria, then you re-enable, right? You want to triage. You want to stop the bleeding and keep the accurate categories running, and then reintroduce it. Then so the last one, this is more CI/CD again, like as well. The severity levels, right? Well, I'll show you later on. You have to be explicit with it, like we were here, right? So for CI/CD code stuff, right? Criteria, we'd have like over here, we'd have like a critical section, right? Important message, medium, low, right? We have the categories, and then we'll put in sort of the criteria for each of those setting or like categories, I guess. And then that will greatly improve our responses. Yeah, see here, attach concrete examples to each level of severity. Yeah. This is also big trap in the exam. You'll notice that a lot of questions, like the wrong answers would be like, only do it if you have high confidence, be extra careful, right? You're trying to fix a decision boundary with a, what's it called? Like a prose, right? Like a wordy thing, right? It's not structured. It's actually, one sec, sorry, I don't see that. I want to see that question. But yeah, if you're trying to give a prompt semantically to fix something, that's when you know you're doing the wrong thing, right? You want to be explicit and show examples. And this is not working anymore. All right, let's do some prompts or some polls. See where everyone's at. But yeah, let's do like an easy question. Let me see just where you guys are at. It'll help. I mean, if anyone makes a mistake, we can go through it. There's not that many of you, so don't be afraid to ask questions. For sure, next time I will enable voice so you don't have to type, because yeah. But yeah, read the question, give it a whirl. Don't look at other one's answers. Try to answer it the best you can. Three responses. I think let's wait for one more. I'm gonna give it this is a nice, easy question. We'll give it like 60 seconds. I guess on this topic too, because while we're here and we're waiting, so we'll cover this later in MCP and tools. But if you do the skill drawer courses, it'll talk about tooling, right? So, when you interact with Claude, right, this is important. So the LLMs themselves, right, you may not know any kind of ML or something like that, but the model itself is trained, on what they call training data, right? And the model doesn't have anything, it doesn't know anything outside of the training data. An example of this would be like, and this is true, and actually I'll get to it, but a smaller example would be sort of, let's say we're training a model and we're scraping the internet, right? But we're scraping only the US internet stuff, right? So everything's in English, right? So it's training data, everything's in English. Now, let's say I get a question in Mandarin Chinese, right? That training data, right? Like it was never trained to learn Mandarin, right? It didn't get any data on it, right? So when you ask it a question, it's like, it don't know, right? It hasn't encountered it. So that's what tools are for, right? So if you, I can prove this real quick to you guys. Let's do Claude because let's ask it. When was the last? Oh. Yeah, see here. So my training data knowledge of 2026, right? So its data is based on that, right? So like for instance, let's say this was 2020. This was based, let's say 2020 was at the time of the election, so this is 2026, so 2 years. So I had this issue when I was haiku. It doesn't know anything past this cutoff, right? So like if you ask it like who the famous actor, RAP, who passed away the other day, right? Claude doesn't know it because it wasn't in its training data. So it has tools basically like the most common one that you can see is that when you're talking to it, it has access to the internet, right? It has a built-in tool for it to go, like, hey, I don't know this, right? Like, who's this person that died yesterday? And it's going to search the internet and then it's going to come back and give you a response. All right. So that response is passed to you. And then when there's other tools, right, the tools are actually your responsibility on your side. So like Plod will send a request in and says, hey, I want to use this tool. And it's your computer that does the tool execution and sends it back to Claude. And then Claude interprets it, right, with the context and then returns sort of this back and forth until it's like, okay, I've answered your question. But yeah, so super easy question. You all got it, right? Let's do 2 more questions real quick. So this is just false positives, right? We want to reduce false positives in a more generalized sense, like in a data science context and stuff like that. The false positives and then the inverse was like fault, not fault. I forgot the exact term for the opposite. It's normally a trade-off, right? You want to balance sort of the negative consequences of having false positives, right? Because sometimes false positives aren't terrible, but sometimes they can be very costly. But that's beyond the scope of this exam. Just giving you an idea of sort of why false positives are kind of a colloquial thing. But yeah, let's give it a minute. All right, this is a nice easy one. All right, so there's 3 of you. Okay, so let's go through it real quick. So yeah, the right answer is definitely B. Don't feel bad for C. Let's just go through them each and see why each is wrong. The revision is shorter. Shorter doesn't mean anything, right? As being precise in your explanation isn't really, I mean, like the benefit may be context, but it's not material. The other one, yeah, this is just a wrong answer. See, this is gonna be tricky. Okay, so having the word flag twice definitely like it can do biases, but it's still like there's no context to that instruction, right? Like if it's just flag, think of it that way. If you get like a instruction and it keeps repeating the verb, it doesn't necessarily change sort of the context of the instruction, right? And then, like I said before, when it comes to false positives, that's your key signal that this is going to be a categorical fix, right? So it's definitely B is the right answer, right? We want to replace any kind of subjective information into a more categorical checkable condition. So you can do that. And then let's do one more. This is going to be more of a hard one for you guys. I'll give you guys 2 minutes until all three of you respond. That's one. Let's get two more. Two. Nice, nice. One more. Oh, three. Awesome. Okay. Cool. Yeah, that's clearly the answer. I think it's kind of easy right now, right? Because it's sort of like it's literally saying semantic and categorical. But that's what I want you to learn, right? Like that's the takeaway for domain 4.1, right? It's categorical versus semantic. Just to go through the other theory, just to show you how kind of things are wrong. This guy too short, right? Adding more subject or semantically subjective requests isn't going to make it more. The decision boundary still isn't as clear. This one is lower the model's temperature. Just in case you guys don't know, model temperature. And then next time I get my pen and paper. It's sort of temperature means like as temperature decreases, right? I feel more. I do it like this. Like I'm more rigid, so I will use my current probability distribution. But when I'm hot, right, like when temperature is high, I'm more creative. Like my other responses will be higher probability, right? Like I'll lower the probability that's most common, and then for the ones that are least likely, I'll do more. This is important for like if you want to do anything creative, a higher temperature will give you kind of more creative, out of the box responses. And then this guy, system prompt to the first user message. Yeah, this is just wrong. So yeah, that's just wrong. All right, cool. So let's move on to few shot prompting. Right. So you're going to hear this term a couple of times. So we're going to do few shot. We're going to do zero shot. Right. Zero shot is basically giving. It's like it's a prompt with no example. Right. They call it zero shot because there's zero expansible examples. A few shot is like you'll see is 2 to 4. Right. You can do a lot more, but like we'll talk about it. You want to give it examples. Okay. So this is really important for domain 6, which is data extraction. This is the canonical data extraction use case. Yeah, so read it here. I won't read it out loud. The main thing for this guy, right, is sort of like if you've done any kind of data extraction and data cleaning, you want to use sort of this few shot example when it's really hard to describe, the differences, right? Like you might get a bunch of, like for instance, I'll give you an example. So like I'm doing job scraping, right? And I get a big job posting, right? Thing, right? And that posting has like the salary, the skills, the experience, what you're going to do during the day, right? There's all this like information, right? And let's say I want to extract all of that information into some sort of structured output that I can use later, right? And then when I'm looking at like I want to give it like if I don't give it examples, it messes up on what it returns, right? It chooses the wrong thing or it outputs like an incorrect format. So you want to be able to do few shot by giving it examples, but you want to give it examples that are just kind of diverse. Because if you do, it's like sort of you want to do it, you want the model itself to interpret sort of the differences that it can encounter, right? Like you want to give it few shot examples, when like describing the differences between these different scenarios is hard to verbalize, right? So you give it like a wide range and you let the model infer, how to do it. And this is surprisingly effective in the context of this exam, right? You want to do 2 to 4. Here's an example. Here, let's say you have a new analyst, right? It's a blank slate, right? Not blank slate, but it's like a model, right? It has training data up to that point, right? Like a human has all its knowledge for right now, right? That's its training data, and now you want to give it a task, right? So if you give him like a 10-page style guide, that's a lot of work. And, he might not actually be picking up on what's most important for the job. But if you give him examples of like, here what we did, here's what we want, here's what we did, and here's why, that analyst is going to learn a lot faster than just reading that and trying to figure out the 10-page style guide. Yeah, so let's go to next. So yeah, let's walk through this. So this is like a few shot set. This is for a CI/CD pipeline. Right. So the first one is like, I want you to report if there's a common code conflict, right? So he says like, it gives you an example of input output. You give the rationale. Right. Severity is here. Severity is critical. Severity is critical. Right. So code conflict is like, I have a function that says, add, right? But in the code, it does minus, right? Very simple thing. That's a code conflict, right? Because it says like, semantically, it says add and it's subtracting. So it flags. Skip is just an example of sort of, you can skip this. And then ambiguous is ambiguous is sort of just it doesn't know what to do. Handle edge cases. So the ambiguous stuff is sort of where you would want the few shot would be the most productive, right? Because it's in the middle in the gray area, right? And you want the model to be able to figure out, that gray area on itself rather than you giving, right? Instead of you giving it a bunch of examples. So the main reason for not giving a ton of examples is you don't want to, wait, there's more questions. Sorry. Okay. Oh, chat is disabled. Okay, hold on. Oh, you just gave this. Can you give me an example of a prompt for future prompting? Can I give you a few shot? Let me think. Do I have one available? Where would I put it? Let me just check a quick. Sorry, guys. Let's see if I have it. I have one. No, I do not have one available right now. I am actually, I do not have one. Yeah, I will get back to you. Let me write your name real quick, just so I remember. Yeah. Okay. It just on that topic too is like when I'm doing for my job pipeline, right? I extract the core things I want from the data set. But I'm actually interesting enough. This is more AI, not an exam. I'll get through real quick just to give you like a fun example. So LLMs are really good for synthesizing data, right? Synthesizing meaning it creates a data set for you. So what you can do, and it's really fun, is you use Claude and Codex to do like maybe 1,000 examples of it, right? You feed it like 1,000 diverse examples. It gives you the data, and then you can actually go later. You can fine tune a model with it. So you get like a model that's like really small, and then it has training data too, right? So it has like a base, but that base isn't as big as like how huge Codex and Claude can, are, right? Because Codex and Claude can do a ton of things, right? But these smaller models are just like, they're like, like second graders, third graders. But you can teach that little second grader, third grader based on those 1,000 examples that it synthesized. And then now you get like this awesome model that can do what Claude does for like a fraction of the price, right? Because like if you notice the cost associated with like output tokens, it can get expensive really fast. So if you fine tune a smaller model, you can get a lot of value and it won't cost you as much, right? So it's actually that's how a lot of models right now kind of like if you look at the boundary of the scoring, right? It's starting to like taper off, and when anyone's behind, they'll like synthesize data from other models to train their models. So it's an interesting kind of arms race. But sorry, that was a detour. And I will definitely give you an example of a few shot. I think maybe I have one later here. I don't remember. All right. Yeah, it's a few shot prompting, which I remember. You want diverse examples, right? If you give it like the same example, just like different words for each of them, is it really providing you any value, right? Like, because you want to think of it from a value proposition, right? Like you want to be able to, like in video games when you have like the pentagon with the skill tree, right? You kind of want to have that skill tree cover the most of that area. So a few shots, like if you give it the same example every time, its skill is gonna like, let's do like strength, intelligence, dexterity, right? So it's gonna go all to the one. But if you give it a good wide range, it's going to be able to do more. But the question becomes, why not more? Like, why not give it 100 examples or even 10 examples? And the main reason for that is just context, right? Like I said, like in the same way of giving the same problem every time, it doesn't really provide much value. If you can give diverse examples, like if you have like really, really diverse examples, maybe you can add more. But for the sake of the exam, the 2 to 4 examples is sort of what they're looking for, right? What else we do? So in context demonstration, that's sort of the same thing of sort of like it learns the patterns. You don't have to explicitly define instructions for it to implicitly learn what it needs to do. Yeah, this is the ambiguous case analysis, so schema conformance. So we'll cover this. This is next section, the schema conformance, right? Schema in the sense that like, I have a data output. Schema you can think of as like easy one is JSON, but if you don't know JSON, if you know JSON, you know JSON. But if you don't know JSON, CSV, right? Like if you have a CSV, it has like, title, back to the job one, salary, location, right? Each column it's like represents a data set or a data point, and then you have a bunch of rows on it. So the schema would be, everything's the same kind of type. Generalization versus memorization. Yeah, that's sort of just a diverse thing, right? So you want diverse examples. Don't get in the model's way. The model is better than you, and it will, just give it a wide range. Okay, so common failures. How much time do we have left? We got a good enough time. And if I get examples, let me actually go down here. No, not that one. Okay, let's keep going. Got common failure modes. Happy pad. Yeah, so you always, even at this point, you just kind of look at the last tab, right? You want edge cases, one skip null cases, right? You want the diversify. This is important for, like I said, like data extraction. It's really good, right? Because if you ever done kind of data extraction, doing like writing regex to find stuff is kind of painful. Like it works, but it's not as dynamic as pulling with an LLM. Also, I forgot to mention this. When you're giving, no prompt, right? 1 sec, sorry. This is when you're giving examples, right? One of the things also you want to do, this is backtrack a little bit. So, like I said before, remember that the LLM has training data, right? Training data is all the information it used to train itself before it got to that point, right? What you'll notice is that the LLM, right, pulled in most of its data, right, is going to be like it's digitized, right? It's not like the model can't read like a physical book, right? So it's all on the internet. And what's interesting is that because everything's on the internet, right, like HTML, CSS, stuff like that, the things that you interact with, they're structured, right? They have tags, you know, like it's like a if you ever seen like a HTML tag, right? Like a let's do insert, right? So like you can have example, right? So like for instance, all of the internet, right? If it's in HTML, there are these semantic tags, right? So when you're actually giving examples to the model, I spelled examples wrong. Examples. Examples. I can't spell. I am sorry. Right. So yeah, you want to do like example. I spelled it wrong again, didn't I? Oh my god. Example. Right. So you have example, right? So then you might do examples, and then inside you might do for like when you're giving the few shot, right? You could do like example one, and my AI sucks balls. Right. So you'll have like an example, then you'll have example one, example two, example three, example four, but wrapping your examples in tags actually has a quite a large benefit. If you don't believe me, when you try doing a few shot yourself, wrap it with these tags, right? Because like I said, a lot of the training data from the LLM is going to be based on the internet, and the internet inherently a lot of stuff has structure that you can exploit. So definitely do that for your few shot stuff. Yeah, here's here. Here's here. So 10 examples included, right? That's waste of context, no signal, right? This hard range, like I said before, is what the exam is definitely going to be expecting you to know. Here's the other one, right? They're all structurally identical. There's no differentiation, so it has nothing to learn from. So you want to do, like I said before, you want to vary the instructions across kind of like different domains. Interesting enough, what you can do here too is ML is not dead. Don't let anyone say it differently. So like if you're trying to pick the best 2 to 4, if you guys don't care, sorry, this is a sidetracking too. I'm just trying to tell you like how you could do this actually in a really kind of like methodical way, right? So like, I have a bunch of examples. I want to give my few shot examples to cover the most diversity. Right. If I want to do varying structure, is what you can do is you can use a clustering algorithm to cluster all of your different types of inputs. And then you can use it mathematically, you can figure out which examples are the most diverse. And then that'll give you a lot of cool value. But that's out of the scope of the exam. Just for the exam, know that, you want to give room for the model to interpret, the differences so it can execute. And here's the last one, right? Doing formatted only proses. You want to wrap it in examples and show the exact format you want the examples. Also, when you're doing this, be explicit on the format you want back, right? So like when we're looking at here, we have the prompt, right? We have our examples, example one, example two, example three, example four, and then the output be like, and please return this output in X structure, right? Like you could do like output result in like Like I could do like this, right? So like what for the job description, if I could be like title. Also, JSON uses double quotes, so don't flame me. Title, right? Gonna do salary. Right. Missing the commas too at the end. And then like description. There. My job description. Right. So then we'll say like, give it to me in this structure. Right. So be explicit, right? Give it the format, give it examples, it'll do stuff. And then, so yeah, the trap here, like I already covered a million times already. You want diverse examples. You don't want a bunch of examples that are the same. Right. It says, because it's like the model might pick up a very specific trait and then ignore other ones. So you want that diverse stuff. Right. Okay. So yeah, how much time do we have left? 4 minutes. We can we'll skip this one. Just to give you an example of the categories for CI/CD, right? We can do critical, right? It's like unparameterized user input in SQL. That's a big risk because a SQL injection right into a database with no rollback on failure. That's just dangerous. High, right? So like this is like theoretically you could just literally copy this as your categorical stuff, and it'll get you most of the way there. Yeah, medium. So like, right. So it goes security, data loss, critical, high, bugs that'll affect people, medium, might cause future bugs, and then low is like style and convention issues, right? You don't want to be flagging this stuff because every dev is going to hate you and not use your product. So yeah, we'll recover real quick. Oh no, I have questions for you. Let's do this fast. Let's knock out these two problems real quick to see where you're at, and then we can recap. Yeah, I'll give you guys a minute or two. There's 4 of you. I'll wait for the 4th one, even if it doesn't. I'll give it like 15 seconds. I'm gonna go through it real quick. Yeah, we're running out of time, so let's do this fast. Yeah, right. You pretty much got it, right? It's you want to learn the ambiguous, the not defined cases. Right. This is just strict limit response. That's nothing. Larger vocabulary. Yeah, no, these are really easy. Sorry, guys. I'll try to make harder questions next time to try to trick you a little bit better. But yeah, you got that, right? We're trying to find ambiguous cases. And then let's do this one. This one's harder. Okay, give it like 10 more seconds. 4 of you. And again, aha. Okay, yay, someone picked something different. Learning experience. All right, so yeah, it's definitely C, but we'll go through real quick. Getting rid of few shot prompting and relying on instructions alone. You don't want to do that. The technical term for this, again, I talked about before, is zero shot. Zero shot meaning there were 0 examples. Sometimes 0 shots enough, but you should use few shot. And then on that topic, how much time? No, we don't have time. I will get back to you. But then what I want to make up a case for is that when you're doing these kinds of stuff, like you're creating these prompts in production for people to use, and your people are depending on it. One of the biggest skill set you need to learn is how to evaluate your models. So you can evaluate between a 0 shot and a few shot, and then if 0 shot does adequate for your use case, there's nothing wrong with 0 shot, right? But on the exam, it wants you to go 2 to 4 examples. And here, like I said, like you want to cover all the edge cases seen, so it can implicitly learn. And then this guy, so 8 examples. 8 examples is okay, but like I said, you want to do lower. Any kind of instruction isn't enough, right? You want to give it structured output. So definitely like generates beyond the examples. So yeah, the trap here was your right here, yeah, you're explicitly trying to tell the model how to handle these edge cases. Writing them in prose isn't enough. It's better to do it in a structured output or structured input, I should say, such as few shotting the 2 to 4. So that was the curveball here. This one was the telling it how to do it. All right, cool. And then, but yeah, so covered over here, right? So explicit one is the decision boundary. It's the semantic versus categorical. Few shot is judgment and formatting, right? So when the instructions are clear, and then you have these issues. So that first half of that sentence is the important part, right? Where your instructions, you can't prompt your instructions any better, and you're still getting issues. So let's give it some structured input to how to judge the outcome. And then, yeah, we'll talk about machine readability tomorrow, Thursday. And that's it. We talked about this, tools, client tools, server tools. Yeah, I think that's it. That's a good place to stop. You guys have any questions? Ooh, here's more questions. Why wouldn't you just use the text editor? Do you have an example, Luke, of what you're asking? I actually don't understand. Can you give me like a little code snippet? Can I make you talk? Can I make you talk? Let's see. Can I make you talk? How do I make you talk? I gotta figure this out. Yeah, Luke, just type in your like example that you're talking about, like just number wise, anything like that.
Hi, Ryan. Can you hear me?
Yeah, I can hear you now.
Yeah. So I was just kind of wondering why you're giving this example where, and this might be a stupid question, but you kind of like you're using the code editor to using this taxonomy to like to list out the examples. But
Yeah.
But why would you? Why wouldn't you just? Why would you do that rather than just like using the kind of like the inline editor just to say, this is example 1, this is example 2, this is example 3?
Oh, I'm still not kind of get what you're asking. Are you saying like when you say in code? Because like what I was editing was a code editor, right? It was Vim. So do you mean
Right.
like inline in terms of the actual LLM, like a chat?
I just think that I'm like kind of a bit confused about like your example assumes that we can like program.
Oh, Oh, I see what you're saying.
Do,
Wait,
do
oh,
you
no, I
see what I
don't.
mean? Like,
So you're saying like, how let's just do this. It's set here. We'll do like a
or is that like is that a prerequisite
no,
for
no,
being
no.
able to?
It's not a prerequisite. The examples I was giving you, like the wrapping of the, like the yeah, examples, right? You can see my thing, right? So you're talking like this part?
Yeah, exactly. Yeah,
So this is like this is just, you don't have to technically use this. I think you can still do like markdown, for instance, where you're like example,
yeah,
right? And then you can do like example, one, or maybe even we can do like example one, or like
yeah.
that. Are you
Okay.
talking? Yeah,
Yeah,
you
exactly. Okay, so you could just do something like that. Maybe I'm just getting a little bit hung up on the format you use, but it sounds like
yeah.
it's fine. Just yeah. Okay.
So you can do it like this. I actually don't know the exact answer. There might be differences. I was just from the AI books that I've read.
Yeah.
This was the canonical example that they use, wrapping
Okay.
it with tags. But it's smart enough to pick up on sort of the structure.
Yeah.
But like I said, the main point is to give it some sort of structure when you're given the few shots.
Yeah. Okay. Cool. Thank you.
No problem. Cool. Any other questions while I have you guys? Yeah, I did cover some stuff outside of the exam, but I think it's good stuff to know. It will, like, you'll eventually have to learn it anyways if you're going to do this in production. Yeah. Okay. If there's no other questions, thank you for your time. It was fun teaching you. Feel free to shoot me any questions. You can reach me at, is it on this slide? Wow, it doesn't have my thing. You can get me at raheemtechcareers.com, or my name and my last name. So Raheem at raheemramzan.com as well. Okay, cool. So you guys can feel free to leave because I don't know how to turn this off.
I'll help you with that.
Awesome. Do I have to give you permissions? Or are you good?
Yeah, I can. I'm going to end the Zoom.
All right, cool.
Okay.